Hi. Good morning, everyone. Very good morning, all of you. Right. So here we'll be continuing our discussions. Right. Again, we are live on YouTube as well as in special classes. Right. In both the classes, we are live in. You can say, right, everyone. Here, this is the seventh lecture. Simple stresses and this is strains, part 7. Right. Seventh lecture on which one? This is simple stresses and strains. You can say, all of you. So, yeah. This gate and ESE PYQs. Right now at present which one we are doing it, that ESE PYQs we are doing now, and we'll be continuing to do with which one, this ESE PYQs will finish off, and after that we'll go for this gate PYQs of this first chapter. Okay, so chapter by chapter gate PYQs as well as this ESE PYQs we'll see together. Right, got it? Now coming to this, all of you, yeah, good morning Pravalika. So all of you, welcome to Unacademy. Let's crack it. Right, everybody get ready to crack, all of you. Right, everybody get ready to crack. Ready to crack, all of you, or not? Right, be ready to crack. So what is that referral code you have to use always? That RP Civil is the referral code you have to use always, right, whenever you are subscribing to this plus and iconic courses. Right, now this is my web link of my profile, and this is the referral code you have to use always. Right, yes, I am good. How are you? Right, so now what we need to do, we just observe, these are all the topics we'll be discussing. Right, these are all the subjects I'll be taking in Unacademy. Yeah, Saint Sinha, hello, good morning. What is it? ST Sinha, Saint Sinha. Right, so here these are all gate 2023 toppers from Unacademy, all of you. Right, within top 10 and latest batches. Right, what is that? Latest batch started, everyone. Right, on 30th August, this latest batch for this 2024 was started, all of you. So Jaspal sir has started with building materials. Right, what is the referral code? RP Civil is the code you have to use for this, everyone. And for this 2025 also the same batch was started. Right, what is it? You can say RP Civil. Okay, good as usual. Okay, same my dialogue only. Very good. Right, here. Right, here if you just observe, right, this is these are the books, additional books, printed books you will be getting if you are taking this iconic subscription. Along with the plus benefits, you will be getting these additional benefits whenever it is an iconic subscription, all of you. Right, whenever you take an iconic subscription, all of you. Right, now these additional books you will be getting, you can say. Right, now this first chapter only we'll be discussing now at present. Right, so these questions, it's seventh lecture and this is simple stresses and the strains, part 7, you can say. So how many questions we have got completed? Right, 45 questions yesterday we have got completed now. So now shall we proceed from this next questions, all of you? 46th question onwards shall we proceed? Yeah, anybody from YouTube? Yeah, 46th question onwards we'll proceed, all of you. I'll try to give the timer 2 minutes time. Sorry, okay, 90 seconds time I'm giving. Try to select the answer, of you. Those who are on special class, you can directly select, click on the option. Those who are in YouTube, you have to write your option there in the comment box or chat box. Okay, nobody selected from special class. Yeah, 100% wrong answer. Rolika said Correct answer. Right. So what is that you are having if you just observe, everyone? So what is this? You can say here Young's modulus, Poisson's ratio, bulk modulus, rigidity modulus, right? So what is that you are having? Lateral strain to the linear strain within the elastic limit, right? What is that lateral strain to the linear strain? That ratio of this lateral strain to the linear strain is your Poisson's ratio B1. B1, how many options are there matching? Option A and B are matching, you can say, right? Okay. I did not ask that. Okay, don't worry. Yeah, shear stress, stress to the strain within elastic limit, right? Shear stress to the shear strain within the elastic limit, right? Shear stress to this shear strain is your rigidity modulus na D3. So B1 D3, right? B1 D3. How many options are there? Only one option. Option D is correct. Option B is correct na? Option B is only correct or not, everyone, right? Option B is only correct, right? Now, bulk modulus direct stresses to the corresponding volumetric strain, right? That is your bulk modulus now. Obviously, that is your bulk modulus or not, everyone. And the next Young's modulus, that is a stress to the strain, right? So here it is not mentioned which type of stress and which type of strain. So, but by default, which type of this stress and which type of this strain we have to consider by default? By default, we have to consider this shear, normal stress and this normal strain. Now, if nothing is mentioned, everyone. If nothing is mentioned, normal stress to this normal strain only we have to consider. Yes, now? Is it clear? Shall I move to the next question of you? 47th question. Right. Shall I move to this question of you? 47th question of you? Yes, I will be moving on to this 47th question. Select the answer of you. 105 seconds time I am giving. Forty-seventh question, select it. So when we are taking 1 hour classes, na, they will be completed very early. So today onwards we'll take 1 hour classes only daily, okay? Every class will be. So that more number of questions we can finish up now. Thirty seconds more time. Why many people did not join in special class? I don't know. Probably said B. Right. 100% wrong answer from special class. Okay. Yeah. So what is this here? Right? A square plate A by A rigidly held at the three edges and it is free to move along this fourth edge only, right? They are in the ghost dreams. Very good. So here what is it you can say? Along the three edges it is supported, right? It is rigidly supported along the three edges, right? But it is free to move, it is free to expand, or this free to move in how many directions you can say? Only in one direction. If you just observe it, this is your square, and if you just consider, right, what is it you can say? All sides are same, right? All sides are same only, no? All sides are same only. This is A, this is A, this is A only. So that is also A only, but all sides are having support, rigid support, but this side it is not having any rigid support, right? So now tell me, free expansion is possible only in this one direction. So like the fourth edge only it is possible to move. If temperature of this plate is raised by the temperature T, right? What is it you can say? That a delta T we have to take it is equal to the smaller T. So it means if you consider this X and Y direction, what is the free expansion possible? Free expansion possible in this X, Y both the directions, or it is possible only in this X direction like this? It is possible only in this X direction like this, na? Is that no? it is only possible in this x direction like this or not, right? Or not, right? What is the delta free na? That is your free expansion possible if you just observe, right? Is not? So that is your free expansion possible if you just observe, right? Isn't it? Yes, I think also answered B correctly, right? Then the free expansion of this fourth edge will be, right? Then the free expansion of this fourth edge will be, right? Considering which one? This coefficient of thermal expansion alpha, modulus of elasticity A, Poisson's ratio mu, right? How can you get that if you just observe of you? What is it? It is raised by this temperature, right? It is raised by this temperature T only, no? Yeah, it is raised by this temperature T only, no? Arey yaar. Why always you are saying that you are waste, you are waste? You have to say yourself that I am best, I can do everything, I will do everything, and you do it and you have to prove it, right? So don't think that always you are waste, right? Because if you just observe, nobody is perfect in this world, right? Nobody is perfect in this world, you can say. Everybody is having some flaws and you also started. It is not the class of demotivation, it is a class of PYQ solving, okay? Right? So you have to be careful, right? No. So here it is expanding in which direction, you can say? It is trying to expand only in this one direction. Nice, no? Aparna, Yashwant, Jagrati, good morning. Right. Jehin, Yashwant. Right, what is it you can say? Total expansion in x direction is what you can say? Whenever temperature is rising or temperature is falling, if you just observe, right here direct because if you just observe what is the total epsilon x, you can say epsilon x is nothing but your, what is it you can say, epsilon x is nothing but your, which one? This is sigma x by a into the sigma x by a minus which one, right? Sigma x by a minus which one, everyone? Sigma x by a minus this is mu sigma y by a minus which one? This is mu sigma z by e, right? When we have to use this, we have to use this, right? We have to use this if it is a load applied or the stresses applied, na? But in the question, are these loads applied or stresses applied given, or which one is given? Tell me all of you. Only temperature is increased, na? Yes or no? Temperature is increased, na? So temperature is increased, na? So as the temperature increases, right? What happens? You can say as the temperature increases, what happens? This x direction value increases, na? Yes or no? X direction value increases, you can say, right? X direction value increases, right? So now tell me, what is this dimension increasing, everyone? How much it will be increasing? Uniform increase in the temperature is there, right? This direction no change, right? This direction only changes are happening, na? This direction are only changes are happening, means, right? What is it you can say? This direction only changes are happening, means, right? What is it you can say, everyone? All of you? So here what is the epsilon x you can get it is, so that is your a alpha t will be which one? This that is your positive, right? Because of which one? Due to expansion in which one? Expansion in x direction due to temperature rise, na? Due to this rise in the temperature, right? Here Ramesh, good morning. Now and what is the epsilon x2 if you just observe? This is your which one? So other directions contraction will occur, na? Whenever it is free to expand only in one direction, means how it is possible? Other directions contraction is possible, na? Other direction contraction possible, right? What is it you can say? That is your which one? This that is your mu a alpha delta t, na? Mu a alpha t, na? So therefore what is that epsilon x total, you can say? What is the epsilon x total if you just observe? That is your a alpha t plus which one? What is the a alpha t plus which one? This is mu a alpha t, na? So what is the total if you just observe? What is the total? A alpha t, if you take a common, 1 plus mu is that answer you are getting, na? So this is due to contraction, right? Due to contraction in others, expansion in x, na? Expansion in this x direction, right? Like that, right? So which one could be the correct answer now if you just observe? Which one will be the correct answer now, right? Option B only will be the correct answer, na? Option B only will be the correct answer, you can say if you just observe, right? Isn't it? Is that clear? Got it? Shall I move to the next question? 48th question of you. I'll be moving on to this 48th question. I'll be moving on to this 48th question. Right, select the answer of you. I'll be starting the poll. Right, 90 seconds, 75 seconds only. Okay, 60 seconds time only I'll give. A for apple, B for banana, C for cat, D for dog. Okay, what is this one now? 48th question. Sai Teja, this is also B for banana. Okay, very good. From special class, Yashwant Jagrati answered correctly. From YouTube, Pravalika Sai Teja answered correctly. So for a linear elastic isotropic material, the number of independent constants are, right? What is the number of independent constants? 2 only, na? Is that no? Do you remember? What is the total constants if you just observe that a total and the number of independent constants if you just observe, right? What is the total? Whenever it is that isotropic and this elastic, right? Isotropic, which one? This is elastic, right? What is it? Okay, isotropic material, what is it? You can say total is 3 and total is 3 or for everyone. Total is 3 or for all of you. Total number of constants will be 3 or for all of you, everyone. E, K, G, mu, right? Total number are 4. And what is that independent? Independent number will be 2, na? Yes, so you are the correct, correct, right? Yes, Jagrita, correct, right? So that is what, right? Independent to why? Because if you just observe E equal to 2G into 1 plus mu, G we can calculate from E and mu, K we can calculate from E and mu, right? If you know 2, you can calculate the others, na? Definitely. Now, whenever it is that orthotropic, what is that you can say? Whenever it is an anisotropic, what is it? Anisotropic, na? Whenever it is an anisotropic, total number of constants will be infinite, right? Independent constants will be 21, right? So we'll come to know about this. What are the 21 constants? In this MTech, there is a subject called as theory of elasticity. In that subject, that will be discussed. Okay, just simply here you remember in strength of material BTech, you remember only the numbers. Okay, next orthotropic, how many? Orthotropic, how many? Total 12. Total 12. Independent are how many? Total 12. Independent are how many? Yes, Sai Teja Pravalika answered correctly. Independent are how many? Independent 9. Total 12. Independent 9. Is it so? Or different? Anyone? Correct only or not? Right. So we'll be moving on to this next one, right? This is 49th question, you can say. Select the answer of you. 45 seconds time I am giving. 49th question. Today we'll solve at least up to 60 questions, so that 15 questions will be completed. Total 150 questions are there in the first chapter. Now I said ESE. ESE itself 150 questions are there, you can say. Okay. Yashwant Jagrati answered correctly. Shravali, good morning. Right. So here, A for apple. Okay, apple. Right. Creep is the gradual increase of, right? What is it? Creep is the gradual increase of which one? This plastic strain with the time at the constant load, elastic strain with the time at the constant load, plastic strain with the time at the varying load, elastic strain at the time as the varying load, right? So it is a varying load or it is not the varying load. It is not of this varying load, na? It is at the constant loading only this happens, or not everyone, right? At the constant loading only this happens, you can say, right? And these are permanent strains or temporary strains, you can say. Those are permanent strains, na? Whenever those are permanent strains, you can call them as plastic or elastic, you can say. Those are plastic only you can call it as, or not everyone? Yes, absolutely right. So question number 50 shall I go for? Question number 50, I'll be starting the poll at 60 seconds time I'm giving. Try to select the answer, all of you. Yeah, sustained loading. Yes, sustained loading means the load is kept as it is, right? It is not changing, it is not varying. Okay, that is the meaning of it. Yeah, those who are enrolling, those who are willing to enroll for this, you can enroll everyone for this batch, all of you. Jagrati from special class answered correctly. Aparna also answered correctly. Yashwant also answered correctly. YouTube, Pravalika and Sai Teja also answered correctly. Very good. Right. So match the properties of list one, right? What is that you can say this last point is your breaking point or this rupture point, na everyone. So this one is matching to which one? This is C, na? So no, one is matching to this C or not everyone, right? So one is matching to this C, na, that rupture point. So ultimate strength, this 2 is matching to this D, na? So no, 2 is matching to this D. And what is that fourth one? You can say proportionality limit, na? That 0.4 is proportionality limit. And this 3 is your yield point, right? Now tell me which one is matching. Very good. Okay, yeah, what is that, which one is matching, right? Option A is matching, na? Yes, option A is matching, right? Very good, very good. Okay, right. So shall I move on to this next one, 51st question? Yeah, those who are enrolling for this, you can just enroll all of you for this new batch is starting. Right, shall I move to the next one, 51st question? Yeah, 51st question I'll be going for. Select the answer of you. 45 seconds time only I'm giving. Pravalika answered correctly from YouTube. Yeah, Stravali only answered from special class. What is that? Assertion. The strain and this stress system for a bar of length L subjected to an axial pull will be the same whether both ends of this bar are free or the end is fixed and the other end is free, right? Yes, na? So stress strain diagram for a bar, it will be same or not everyone? Obviously it is the same only, na? Yes or no? Because that is the load deflection or this stress strain curve is related to this it is related to these dimensions and conditions, or it is related to this material, you can say it is a material property or it is a dimension or end conditions property. It is a material property, na? Whenever that stress strain curve is a material property, right? For the given material it will be same, now whatever is the condition it is having. Yes, reason rigid body displacements have no effect on these elastic deformations, right? Yes, na? Rigid body deformations are having no effects on these elastic deformations. These elastic deformations are different. What is it? These are under the action of load. Rigid body deformation means entire body is moving from this place to that place, you can say, right? One room to other room, that this body is moving, then that is rigid body motion. But external load effect is different, na? Whether it is here or it is there, it does not matter now. Whatever it is the location of this member, that external load effect will be same only, no? So external load effect is the same, means what is it, you can say that elastic deformations which are created due to the load will not be affected by this rigid body deformations. Now obviously Yes, obviously correct or not? Yes, because of this only, what is that you can say? Whether ends are bar or ends are free, right? Ends are fixed, right? Whatever it is a condition, it is the same, you can say it. It is the same, you can say, right? So which option can be correct one now? Which option will be the appropriately correct one? Rigid body displacement without acceleration has no effect on this elastic deformation, right? Yes, now obviously. So that will not change the strain in the member now, because stress is developed due to the resistance, which is the same in this case now, whether you are having this fixed end or free end or whatever it is, right? So both the assertion and the reason correct or not? Correct. And correct explanation only now? Yes, correct explanation only, you can say. Now we'll go for this next question, right? 52nd question. Try to select the answer of your 90 seconds time I'm giving. Or okay, I'll give 130 seconds time is available. So many Rakis. Not so many, yeah, 4. Select the answer for this, all of you. Jagrati from Special answered correctly. Pravalika from YouTube answered correctly. What about the others? So from today onwards, we'll take these classes 1 hour, right? So 10:30 to 11:30, this is SOM class up to third, first, second, third. And after KP sir again comes to online classes, na? Then again we'll change according to KP sir classes timings, okay? Morning our regular time we'll keep it, right? 8:30 to 9:30, and again this one 10 to 11, okay? Aparna Yashwant also answered correctly. Right, Savali also answered correctly. Right. So Atija also answered correctly from YouTube. The bulk modulus of elasticity of the material is twice its modulus of rigidity. So what is it given? Bulk modulus is 2 times, right? So that means K is equal to the 2 times its rigidity modulus now. Then the Poisson's ratio of this material is. You are asked to identify this Poisson's ratio, right? How can you get that? E equal to that 2G into that 1 plus mu. Right? E equal to which one? This is 3K into that 1 minus 2 mu. No? We substitute that 2G into that 1 plus mu is equal to which one? This is 3K into that 1 minus 2 mu. Now 2 into G as it is into 1 plus mu equal to 3 into, in place of K what you can write? 2G we can write it into that 1 minus 2 mu. So what happens? This 2G, that 2G cancels now. 1 plus mu equal to 3 minus this is 6 mu, right? We send this 6 mu to minus 6 mu to left hand side, it will become this 7 mu equal to 1. If you send it to right hand side, 3 minus 1 2, it will become, therefore that mu will be equal to that 2 by 7, right? Poisson's ratio. Is there any option with that? 2 by 7, option B will be the correct answer now, everyone, right? Option B will be the correct answer, you can say, right? Like that. Shall I move to the next question? 53rd question. 53rd question we'll move on to, right? Try to select the answer of you. 45 seconds time I'm giving. Yashwant answered correctly. Jagriti also answered correctly. Pravalika, Sai Teja also answered correctly from YouTube. Green apple this time. Very good. I think you are doing apple farming. Send some apples, one basket of apples to everyone. Creep of a material is a property indicated by, right? What is the creep of a material? Time dependent strain of this material, elongation of this material due to the changes in the material property. It is due to the changes in the material property, no, no? Shortening caused by the shrinkage of this member, no, that is not a creep, that is a shrinkage only. The decrease in the volume of this material affected by this material, that is also shrinkage only. Which one is a creep? Only time dependent strain. When you are applying any load for more amount of time, even though it is within the elastic limit, that will create permanent deformations now. That is a creep, you can say, right? Shall I move to the next question, 54th question? So 54th question, right? Try to select the answer. Because I am only giving fun. Okay, very good. Aparna answered correctly. That is B for banana. Okay, very good. Sai Tej also answered correctly. Right, resilience, what is it? Maximum strain energy, recoverable strain energy, right? So resilience is the strain energy stored in the body within elastic limit up to any point. Up to any point, you can say it need not be up to the elastic limit fully, but within the elastic limit, right? Within the elastic limit, either it can be up to this point or it can be up to this point, right? So but it should be within the elastic limit, right? Strain energy stored in the body within the elastic limit up to any point, then you can say it is a resilience, right? Proof resilience means it is exactly up to that yield stress, then you can call it as this proof resilience, na? Is that no? Right, now coming to this next question, 55th question of you. Select the answer of you, everyone. Any other answer, brothers? Yeah, nobody from YouTube. So what is it? You can say the normal stress of one. Okay, don't worry, we'll see. Normal stress of one nature compressive or tensile acting along one of these three orthogonal axes of a member will produce strains of this same nature in this direction and strains of opposite nature along the other two directions. It's not, if a compressive stress is applied in this x direction, compressive strain will be created in the x direction, and yz direction tension will be created. Suppose if tensile stress is applied in this x direction, in the x direction tensile strain will be created, and the y and z direction compressive strain will be created, right? That is correct or not, everyone? Yes, that is correct only or not? One direction, if it is tensile stress or tensile load, if you are applying in that direction, same nature of this strain, opposite direction opposite nature, other directions opposite nature of the strain. That is correct or not, everyone? Everyone, that is correct or not? Is not? Now reason, sum of these strains along the three orthogonal axes is equal to the volumetric strain, that epsilon v is equal to epsilon x plus this, epsilon y plus this, epsilon z. This is also correct, but do they have any relation? Do they have any relation? Are they are they related to each other, or they are independent statements? They are independent statements now. One is not related to the right. So which option is correct now? Option B will be the correct option or not? Option B will be the correct option, you can say, right? Is not got it? No. What should be the reason? Because of this Poisson's effect it is happening, right? Because of this Poisson's effect, material adjustment will happen. So in that process, right, one direction tension means other direction compression it will create, right? Like that. Got it, everyone? How, what should be the reason? So that is not the correct reason. Now shall I go for this next question, 56th question? I'll be going for this, right? 120 seconds time I'm giving. Try to solve this, all of you. I told you not 2 classes I'll take SOM, 1 class I'll take survey, then again 2 classes SOM, 1 class survey, like that we'll take. Okay. No. These questions are not completed in the previous class. Up to 45th question only we have done in the previous class, yesterday's class. Yeah. Pravalika said, yeah. Any other answer by that? Should I increase the timer for special class? Yeah, previously we have solved all this ESS. Previously 2 years back or 3 years back we have solved. 2 years back I think. 2.5 years back we have solved. Not last year also. 2.5 years mostly, almost 2.5 years back we have done this same. There GATE PYQs, CSE PYQs, SSC JE, State PSC, all PYQs, some almost some 3000 questions we have solved, it seems. Yashwant Jagrati answered correctly. Right. A rigid bar AC is supported by these 3 rods, right? Rigid bar AC will be supported by these 3 rods, right? These 3 rods now, 3 rods of this same material and of the same diameter, right? But the lengths are only different now. A force P is applied such that the AC continues to remain horizontal, right? AC will remain continuous horizontal. So means AC remains horizontal means, right, what is it can say? Strain compatibility is possible. What is the meaning of this? Strain compatibility is possible. So this is your first one, let us say. This is your second one, let us say. This is your third one, right? What does it mean? That means that delta 1 is equal to that, delta 2 is equal to that, delta 3. Can we say from this statement it remains horizontal, right? It remains horizontal, right? It remains horizontal means what is it you can say? Deformation in both will, all the 3 will be same now, isn't it? All the 3 will be same in the same or not? Yes, all the 3 will be having the same deformation, you can say, right? Now total load P will be shared by which one? This P1 plus this P2 plus this P1 plus this P2 plus this which one? This P1 only, you can say, right? You just make it as 1. Why you make it as 1? Because both are same now. Left side and this right side both are same now. So that is what delta 1 is equal to the delta 1 is equal to the again delta 1, right? Because left side and this right side ends are same now. So like that we'll write it. So what is the P you can say? That is your 2P1 plus this P2, right? 2P1 plus this P2, right? This is equation number 1. Okay. And now delta 1 is equal to the delta 2, right? What is the delta 1 you can say? That is your force in that first member, right? What is it you can say? That is your P1. Force in this middle member, let us say that is your P2. Force in this third member is also, let us say, that is your P1. So P1L, what is it you can say? P1L, right? What is that length? L1, right? P1 L1 divided by this AE na equal to, what is it you can say? P2 into L. What is the L you can say? Length of this second member is what? 2L na 2L1 divided by this area is the same, cross section is same, material is same, right? Area of cross section and material are same, right? These two, this cancels, right? Therefore what is that you can get it? P1 is equal to the 2P2 na. Can you say that P1 is equal to the 2P2? P1 is equal to the 2P2, right? So the forces in each of these bars of the shortest and this longer bar respectively are, right? How can you get that if you just observe now? By solving these equation numbers 1 and 2. What is it? By solving this equation number 1 and 2, what is it you can say? P equals to 2 times that P1, right? So 2 times, what is it you can say? 2 times, already 2 is there. P1 how can you write? 2 times P2 now? 2 times P2 plus this P2. So what is it you can say? That P will be equal to that 5P2. This implies what is it P2? What is it P2 you can say? 1 by 5 times this P now. 1 by 5 is nothing but your 0.2 times P or not all of you? 0.2 times this P if you just read. That is how much? 0.2 times this P, right? Now tell me what is that you can say P will be equal to. So 2 times this P1 plus this P2 is what? 0.2 P if you just read. What is that P1 then? So 0.2 P it will go to left hand side, 0.8 P. 0.8 P by this 2 is what? 0.4 P na. Yeah, Palash, Akshay, good morning. P1 is 0.4 P. P2 is which one? This is 0.2 P. 0.4 P and this is 0.2 P, right? Which one is the correct answer? Option A will be the correct answer, all of you. Option A will be the correct answer, you can say. Got it? Right? So shall we move to the next question, all of you? 57th question, shall we move on to all of you? 57th question, right? Try to select the answer of you. So strain energy also we are solving in this chapter only, first chapter only, simple stresses and strains and strain energy, both we are solving in this only. Okay, Anamika, good morning. Seventh question, what is your answer? Prolika said C from YouTube. Any other answer by others from YouTube and special? YouTube 100% wrong. Sorry, special class 100% wrong answer. Meow cat. C for cat. Okay. Yashwant answered correctly. What about others in YouTube? Others are not answering in YouTube. Why? Do you remember direct expression? If you remember, right, what is that? Whenever a member is subjected to this axial force P, right, what is the strain energy? Do you remember? That is your P square L by this 2AE na. But here in place of this P, what is it you are having? This W. So then what it will become? That is your W square L by this 2AE simply. So which option is correct? At option C. Or you can also write it as this strain energy will be equal to which one? This is a half into load into that deformation. Right? What is the deformation? That is PWL by this AE na. So what it will become? That is your W square L by this AE. Strain energy will be equal to which one? This is a half into that load into the deformation na. Like that, half into that load into the deformation, you can say, right, like that. Shall I move to the next question? 58th question of you. Yeah, 60 questions we should solve at least, right? 58th question will solve 2AE. Yes, 2AE. WL square by this 2AE, correct. Yeah, 2 will be there na? So this is 58th question, right? Try to select the answer of you. 45 seconds time I'm giving. Yashwant Aparna from special class answered correctly. So at least 15 questions we have to do today. More than 60, 46th onwards we have started now. So at least up to 60 we have to solve. 15 seconds, 15 minutes more time is there. We can solve. We can cross 60 also, no problem. Like that, within 4 or 5 days, first chapter can get completed, na? Like that, if you do like that. Yashwant Aparna answered correctly. Or within 1 week it may be completed. Elastic limit is a point up to which the stress is proportional to strain. Do you give guarantee that stress is directly proportional to strain? This is your proportionality limit, and what is that you can say? This is your elastic limit. Na? Some portion it may be, some portion it may not be, right? At which the elongation takes place without application of this additional load. That is plastic, na? Up to which if the load is removed, original volume and shape are regained, right? Yes, now option C will be the correct answer, right? So up to this elastic limit, what will happen? If you remove the applied load, it will regain the original volume. It will regain the original volume means that the dimension, it will regain the original strains, na? So no, it will get their original shape, na? It will get their original shape, it will get their original size, you can say it like that. Yes, na? Shall I move to the next question, 59th question? Right. This is ESE 2003 question. Select the answer. 45 seconds time I am giving all of you. Yashwant Jagrati from special class answered correctly. This also, ma'am, only. Okay. Isotropic. So here the time dependent stress strain, no plastic zone, identical properties in all directions, right? Isotropic is identical properties in all directions. Now that is A3 matching. A3, how many options are there? A and C are there. D you can eliminate, right? So here yeah, homogeneous, similar properties throughout the volume, na? That is your B4, na? Yes or no? B4, right? A3 and this B4, right? Which option is matching? Option C is only matching, you can say, right? Now brittle material means what is it, you can say? No plastic zone will be having for this brittle material or not? Or time dependent stress strain? Which one? There is no plastic zone, there are no deformations, na? Yes or no? There are no deformations, directly it will fail, na? If it is a brittle material means viscoelastic will be time dependent stress strain curve, right? Yes, na? That is viscoelastic. After some time it will be acting like a viscous material as well as this elastic material. Right? So now what is that, you can say? If you just observe, this is 60th question of you. Anyone? The material in which the deformation is possible, right? What is the deformation possible, you can say? This deformation, which deformation is possible, everyone? Okay, yeah, I'll start the poll. 30 seconds. Okay, okay. Jagrati Yashwanta pronounced correctly. Right. So here what is it, you can say? The material in which the large deformation is possible, right? Which type of material large deformation is possible before the failure? Before the failure, large deformation is possible in the brittle material, or large deformation is possible in the ductile material only? Before the failure, that large deformation is possible in the ductile material only, no? Yes or no? No. 61st question. Select the answer. Yashwant Jagrati answered correctly. Right. What is that, everyone? As per the elastic theory of design, the factor of safety is the ratio of, right? What is the factor of safety? You can say failure stress rate, that is yield stress divided by this working stress. No? Yield stress divided by this working stress. So according to that elastic theory means beyond the elasticity, beyond the elastic property, if it crosses now, then it is assumed to be failure, right? So yield stress to this working stress, you can say, right? Yield stress to this working stress will be taken as which one? This factor of safety, right? So shall I move to the next question? At 62nd question of you. 62nd question. Select the answer, everyone. Aparna Yashwant Jagrati answered from special. What about the people from YouTube? YouTube, nobody answered. Right, 100% correct answer from special. The principal strains at a point are 800 into this 10 power minus 6 centimeter per centimeter plus 400 minus 1200 centimeter, that same. Then the volumetric strain is equal to, right? What is the volumetric strain? Epsilon 1 plus this, epsilon y 2 plus this, epsilon z now, or you can also write it as epsilon x plus epsilon y plus this, epsilon z now. Now what is that? Plus 800. The first one is what? Plus 800 into this 10 power minus 6 plus what is it, you can say? 400 into the 10 power minus 6 minus 1200 into the 10 power minus 6, right? What is that net value comes to be? Is it not 0 volumetric strain? Is it not that 0, that volumetric strain? That strain will be, volumetric strain will be 0, no? So no, that volumetric strain will be 0 or not, everyone, right? That volumetric strain will be 0, right? Which one is the correct answer, right? Option D will be the correct answer, na? Option D will be the correct answer, right? Got it? Shall I go to the next question of you? 63rd question. Select the answer. Yashwant answered correctly. Right. Okay. Right, Abhishek. Good morning. So the stresses in concrete, right? The stresses in concrete, right? The stresses in concrete, right? What is it? You can say the stresses in the concrete in a reinforced element under the sustained load due to creep, right? How they will increase, whether it is a concrete or it is a steel or whatever it is a material. Whenever the creep strains are increased, stresses will be constant or stresses will be changing? Tell me. Stresses in the concrete in reinforced concrete element under the sustained load due to this creep, right? What is the you can say? Stresses increases with time, decreases with time, this remains unchanged, and this fracture. What will happen to this stresses, everyone? Stress relaxation due to that creep at the sustained load will occur, na? It will result in this decrease in the stresses in the it will result in this decrease in this stresses, right? Stress relaxation will occur because of this creep, right? So in the pre-stress also we'll consider this, not? Do you remember? So this is decreases with the time, you can say. This is 64th question. Select the answer. 45 seconds time I am giving. So 65 questions will solve and stop. So that total 20 questions will be over today. Tomorrow also we'll try to do 15 to 20 questions. Tomorrow also morning 10:30 SOM class only will be there. Aparna answered correctly. Yashwant and Aparna answered correctly from special. YouTube, nobody is answering from YouTube. Right. So what is that? We just observe. A brass bar of this solid section is encased, right? Encased in a steel tube, right? Tube is that steel, and that rod is of which one? This brass, you can say. The coefficient of expansion of this steel is this much, and the coefficient of expansion of this brass is this much, right? Alpha of this steel will be higher or brass will be higher? Alpha of this brass will be higher than this alpha of the steel. Then the composite bar is heated through 60 degrees centigrade. It means that delta T increases or decreases. Now tell me what happens if you just observe because of this. What happens? Tell me, all of you know. Because this is a rigid one you are having, right? Here it is a support. So what they will try to do? So brass will try to expand more, right? Brass will try to expand more, right? Higher, whenever temperature increases, right? Higher alpha material will be under this compression. Na? Higher alpha material will be under this compression. Lesser alpha material will be under this tension. Na? Higher alpha material will be under this compression and lesser alpha material will be under this tension. Yes or no? Because brass is having more alpha, it will try to expand more, but what the steel will do? It will try to restrict the expansion of it, right? So how it is possible? It will reduce expansion, means compressive only, no? Now steel will expand lesser, but brass will make the steel to expand more, means how it will be expanding more than its possibility whenever it is tension. So now which one is correct? Second and fourth are correct, right? Option C will be the correct answer, right? Like that. So shall I move to the next question? 65th question, last question. 65th question, right? Select the answer of you. 120 seconds time I am giving. At 12 o'clock, you will be having that engineering mechanics, that concept of questions will be there. Na? Friction discussions will be continued in today's class. Jagrati answered correctly from special class. Only Jagrati answered. What about the others? This is ESE 2005 question, you can see. Aparna also answered correctly. Simple stresses and strain energy also will be discussed in this part only. A mild steel bar of this square cross section 40 mm by this 40 mm. So that is area of this cross section is equal to that 40 into that 40. Now is 400 mm long, right? What is L equal to that 400 mm long? Is subjected to longitudinal stress of this 440. Means can we say that is your sigma x is equal to that 440 MPa and a lateral compressive stress, right? Means sigma y, right? Sigma y is equal to which one? This sigma y is which one? This is 200 MPa. So what is the first one? That is 440 MPa, that is the tension. This is your compression in the perpendicular direction, right? What is that you can say? E will be equal to, right? Sigma y is equal to the minus 200 E will be equal to 2 into 10 power 5. E will be Young's modulus. E will be equal to the 2 into 10 power 5 Newton per millimeter square. And what is the Poisson's ratio mu given? Poisson's ratio will be equal to the 0.3. Then what is the you are asked to identify? What is the approximate elongation of this bar in the length direction, right? How can you get that? If you just observe this epsilon x, is not length direction, you know, epsilon x will be equal to which one? This is sigma x by a minus mu into that sigma y by a minus mu into that sigma z by e, right? So that sigma z is not there, so you just take it as 0. What is the sigma x? 400 na? So plus 400 divided by this e. What is the e? 2 into 10 power 5 minus mu is 0.3 into what is the sigma y you are having? Minus, that is compression, no? Compression means minus 200 na? Minus, that is 440. Okay, first one is 440. First one is 440. This is 200 divided by this 2 into 10 power 5 is equal to what is it? You can say delta L divided by this, right? What is the epsilon x? Delta L by this L na? Delta L divided by this L is how much? L is what is that length? 400 millimeters is the length na? 400 millimeters is the length, right? Therefore tell me what is the delta L? How much you are getting? How many millimeters is the delta L? It is plus or minus? How many millimeters? How many millimeters? Everyone? 1 millimeter plus only or minus 1? Minus, plus only, plus 1 millimeter, right? So which one is the correct answer? Option D will be the correct answer, na? Option D will be the correct answer here, right? Like that. Is it clear? Shall I close the session? Right, I'll be closing the session. Today we have done 20 questions. Right, tomorrow also we'll try to do 15 to 20 questions in between, right? So thank you guys. Have a good day. Thank you, all of you.